Hello friends, welcome to our channel. Let's look at today's daily challenge problem, zero array transformation 1. In this video, we're going to use line sweep algorithm to address the problem. So here we are given an integer array called nums of length n, and also we are given a 2D array called queries. So each query is a 2-element list. So for each query, we can select a subset of indices within this closed interval in nums, and we decrement the value at the selected indices by 1. So we want to check if after applying all the queries, if we can make the nums a zero array by optimally choose subsets respectively. So if you look at example 1, so its query is from index 0 to 2, right? So each of these 3 positions you can decrement by 1. But if you can choose the first one and the last one and decrement it by 1, so you will get 0, 0, 0. So this is true. Well, for the second example, so from index 1 to index 3, you can decrement by 1. And from index 0 to index 2, you can decrement by 1. But this way, by no means you can decrement the first number 4 and to be 0, right? So this should return false. So here the length of the nums can be as long as 10 to the power 5. So this is a decent large number. So we need to think of term complexity. And the second one is nums is non-negative, right? And those last three are some consistency assumptions. So with that said, we are ready to expose the main idea. The main idea actually is rather straightforward. So basically we want to check after we applying all the queries, we check for each number in nums, what's the maximum amount we can subtract from it, right? So in order to make all numbers in nums 0, so we need to subtract amount is no less than the number itself, right, for each number. So therefore, first we want to get the subtract amount. So this is exactly where the line sweep algorithm works, right? So here, first I'm going to initialize this n. So it's a nums, so the length of this nums. And then I'm going to initialize an array to store those increment amount. So here we should consider a list of length n plus 1. Notice the plus 1, because we are going to consider the indices. So the indices running from 0 to n minus 1, but we should have n, the index n, to make it auto-bound. So now let's look at the line sweep. So basically for L and R in queries. So actually we can consider decrement, right? So from index L, you are going to decrement. So we are going to write this decrement by 1. And then after we exit this range, R plus 1. So we are going to add back, right? So this is the one way. So here I'm looking at the negative part. Then later I'm going to do summation. But you can also change this to be plus and then a minus. So this will be the genuine amount that's to be subtracted. So here let me just use this to directly get the negative, right? So you can print out this to get an idea. So for this example, it means that from index 0, you can subtract 1, then subtract 1, then subtract 1, you get negative 1, negative 1, and then afterwards you should add back. So similarly for this one, so starting from 0, you should subtract 1, and then from starting from index 1, you should subtract 2, because we need to compute the prefix sum. So now let's compute the prefix sum. So here I separated this, but you can actually write it in the one for loop. But let me do this. For I in range 1 to n plus 1, then line I incremented by line I minus 1. So you can print this line again. You will get the amount to be subtracted or the negative one. So for example, let's look at this example, right? So this is the example. This is example 2. So the first number you can only subtract 1, so you get 3. And for the second number, the maximum amount you can subtract is 2, so you get 1. And for the third one, you can make it 0 because the maximum amount you can subtract is negative 2. So with that said, let me let me first get the return and then do some. So its estimate will be the following. So y plus delta, right, for y and delta in zip. So we can use zip nums and also the len. So notice that len is one longer than this nums, but it does not matter because zip will stop at the short one. So what we want to request is the max of this estimate is less than or equal to 0, which means that we can make every number 0 if we want. So if we run it, it passes the 2 cases. Now let's look at the generic case. Yeah, it passes all the cases. Right. So you can actually release this print to check the amount to be subtracted. So for example, here for the first example, for the first case, this is 0, 2, and let me run it again. Right. This is the first one, right? You can the first element you can 1 minus 1 will be 0. So the second one, if you do it's original 0, you don't need to choose it in the range of indices in any query. So for the third one, so you can make it 0 also. So this is the same for example 2. For example 2, for example, the first number is 4, but you can only subtract 1. The second number is 3, you can only subtract 2. For the third one, you can subtract 2. For the fourth one, you can subtract 1. In other words, you can make the last 2 numbers 0, but you can't make the first 2 numbers 0 because the overall estimate, even you choose all the indices when it's in bound for each query, you still cannot do that. So that will be the full video for this problem. So you are welcome to check out other videos in our channel for more practices. With that said, thank you for watching.